Hello everyone and welcome to this system design mock interview. I'm really pleased to say that today we have a ex-senior software engineer at Amazon with us as my candidate. He's going to show you what a really good system design answer looks like, and he's waiting, so I think I'll introduce him now. Tim, how are you doing?
Hi, Tom. Pleasure to be here.
Pleasure to have you on. I really appreciate it that you're doing this with us today. Before we get started, why don't you quickly introduce yourself so that people know a little bit about your background as a software engineer?
Yeah, I have about 30 years of software engineering experience. I served a 2-year stint in Amazon Web Services, working in their self-developed routing platform, and now I work doing embedded router development at Ciena.
Cool. And what Tim hasn't mentioned is that he's also a coach on our platform and has helped lots of people get offers at Amazon and other big tech companies. Right, Tim, if you're ready, let's crack on with the question. Tim, how would you design a phone company billing system?
Okay. So let me ask. That's potentially pretty wide area. It covers a lot. I'm going to imagine that this is the billing system for capturing phone calls. So the basic requirements for this system are the ability to determine what billable phone calls the user made in the past month billing period, for instance, and generate a bill to them for that. Is that along the lines of what you had in mind? Okay.
Yeah,
awesome.
that's what I had in mind, exactly.
Okay, so I'm going to capture that as a functional requirement. And I'm going to imagine that this system supports users having multiple different plans about how they're billed, but those are probably not too relevant details. We want to be able to have a system that accommodates that, but that's not too important to our overall system. Let me ask you, these days, there are a lot of different services that you can get from your phone company, caller ID, call waiting, answering services that might be billable. Do we want to sort of think about charging for and tracking usage of those types of services, or focus more on standard phone calls?
Yeah, I think for the purposes of this interview, let's focus on the core billing services, so phone calls, basically.
Okay, and so we won't, for instance, cover data usage for cell phone plans, or?
Yeah, I don't think we need to get into that.
Okay, sounds good. Okay, and do we want to focus? So I'm thinking the part that is most interesting to talk about is that actual mining of usage data and then being able to generate the basis for a bill, but not, for instance, the payment transaction part of it. For instance, how the customer pays their bill, it would be more about generating the bill, the information needed to bill the customer.
Yes, yeah, I think that's right. We want to focus on the generation, but I also would like to see. I'd like it to be clear in your design where a bill generation system would integrate into this core framework.
Okay, that sounds great. Yeah, thank you. Okay. Okay. And okay, so that's great. And would this be like for a regional carrier, national carrier, international carrier?
Yeah, let's say a national carrier that covers North America.
Okay, North America. And what would be like the subscriber volume, or total number of subscribers this carrier has?
Let's say around 50 million, about 50 million people.
Okay, sounds good. Okay, thank you. And okay, and in terms of the framework, the IT or data framework that this billing system is going to integrate with, are there any constraints or assumptions you want me to make, or can I kind of propose what I think would make sense?
Yeah, I think you go ahead. You go ahead and make some assumptions, and if they're not correct, or if I'm not thinking along the same lines, then I'll let you know.
Okay, that sounds great. Okay. Okay, so I think this sort of covers my functional requirements, at least at a high level. Maybe I might add some more to these as we go along. So in terms of non-functional requirements, let me think about what some of those might be. Okay, so typical ones that apply to most of these types of problems are scalability, availability, performance, and security. Okay, so in terms of scalability, we have to be able to cover the subscriber base, essentially, and the total number of records that are going to have to be, we have to generate, essentially 50 million of these billable records, statements essentially every month. So 50 million generated a month. And we should probably think about what our overall call volume is. So if we have 50 million subscribers, how many, we're going to have to make an assumption about how many billable calls that the typical subscriber makes every day. Now, in my experience, of course, most of the calls I make today are non-billable, right? But maybe we want to, in fact, I might make, only, one or two billable calls a year, really. But maybe that's not so interesting for this problem. Maybe we want to assume a system where basically you get less included with your plan and you're charging for more billable calls. What do you think, Tom?
Yeah. Let's say this is kind of a budget package, should we say, a company appealing to a more price conscious market, and so less is included in the plan, and so they're more likely to make billable calls outside their plan.
So maybe we'll just as a rough thing, I'll say a typical customer might make 10 billable calls per day. We'll sort of make it a worst case then. 10 billable calls per day.
Okay.
Does that sound all right?
Yeah, it sounds like a lot, but I think that'll make for an interesting answer. So let's go for that.
Okay, so 500 million calls a day. Total of 1.5 gig. 1.5 billion calls per month. So that's definitely a lot of data that we're going to need to kind of process through to get to generate these bills. So let's see. Okay, I think scalability. We need the system to be able to collect and generate this much data. Performance. I think we're kind of fortunate here that this is not for the most part, a real-time performance-based system. But that's an important question that I need to ask. How soon after the billing cycle ends do we want this data to be available?
Oh, I see. Yeah, good question. Let's say 24 hours once their bill cycle ends.
So that's actually pretty forgiving, right? So we actually, once the bill cycle ends and the sort of source data has been finalized, we have 24 hours to process through that and generate any individual customer bills. Should we assume that the billing is there's a regularized billing cycle where everybody, for instance, is billed at the beginning of the month, or that the billing cycles are going to be staggered based on when the user joined, started their plan, for instance?
Yeah, I think now most are staggered, right? So let's say, if they started on the 13th of the month, then their plan goes from the 13th to the 12th. Yeah.
Okay. So in some ways that makes it easier for us because staggered data means less load on the system, as opposed to having a really high. The system essentially has 1 day a month to do all its work, but it also means that the load may not be consistent, right? There may not be an equal distribution of when people started their plans. So we'll probably want to consider how the load can be scaled elastically to handle that aspect of it.
As Tim did here, you should ask clarifying questions to ascertain the functional and non-functional requirements of the system. These will act as guideposts as you move forward in the design. To help you think through your high-level design, you'll want to make some estimations of relevant metrics, as Tim did in this case for calls per day and calls per month. It's generally good to also arrive at a ballpark calculation for transactions or operations per second, in this case, calls per second. Of course, you don't want to spend too long stuck in the numbers, so keep it ballpark and be well practiced at dealing with large numbers and making quick calculations.
Okay, so I'm thinking just as a high level kind of model for operation of this service is essentially it's a data management, data creation problem that we are starting with. We are pulling data out of some sort of database of calls. So there must be a call records database that is maintained by our organization's call control framework. So this is the part that actually handles and places your telephone calls and so as you are actually making calls, that the records of those calls, to phone number, duration of the call, that information would be populated into this call records database. Let's create another text box. So I'm going to just lay out a basic schema there. And there may be other metadata that we could collect about the call here, but that's the basic stuff that we need for debilling. So I'm imagining then that, and there would also be a second database, which is kind of taken as a given or a starting point, that would be data about customers. And so that would have information like, customer name, address, etc. Phone plan, number of lines / numbers, and essentially each number that exists under their plan. Yeah. And so given that we're starting with these two databases, and so this part, or let's create another one. There would be a whole customer plan management system that enrolls customers into our service, gets their billing, etc. information, sets them up with telephone numbers, etc. I'm assuming then that is also kind of a given starting point, that our design isn't going to cover how this call control framework works, how this customer management part works. Just assume that those systems exist and are populating this database with information that our billing system is going to need to function. Does that sound like a reasonable approach?
Yeah, that sounds reasonable. I'm on board with that. Mm-hmm.
Okay, great. So we have those. And so at a super high level, how our system is going to work is it is going to have a billing service that is going to mine these two databases on this periodic basis to there's a sort of a issue about, I'm going to use, what does an arrow mean? Does an arrow mean that a component initiates a request, or does an arrow kind of represent a flow of information? So in this case, I'm going to propose that the arrow is going to represent a flow of information. So even though the billing service is going to be initiating requests to the call records database, I'm going to show the arrows going from the call records database to the billing service to show that that's how the information flows, if that sounds okay.
Yep, thanks for clarifying that. I think that's fine.
Okay. And so this billing service is going to be on a periodic basis mining these, essentially looking for customers whose billing cycle has ended, then going and mining the call records database for their billable call history and using that to populate essentially a billing statement database. And this could be the record of all the billing, essentially all the bills that are generated for our customers. And essentially we have sort of two levels of information: the bills that we are generating for the coming month that we expect people to be accessing and paying off in the coming month, but also obviously we want to maintain the customer's billing history going back indefinitely. And so this would essentially be, the list of calls that the customer made during that time period, how much we're charging for them. So let's see, I'll create as well as things like the base cost of the base cost of their plan and services that they've provided. So I don't want a box here. I want a text. Nope. Okay. I'll just throw this off to the side here because I didn't want a box. I wanted a text box. Okay. Okay. So this is a real high-level view of what I'm imagining the main components of the service would look like. Then the billing database will have two main customers. One might be, at least two main customers or users. One might be a customer billing portal, like a website where the customer goes to view and pay their bill. And another might be a customer bill generation. So this bill generation service would be the thing that actually gets your billing record, sends you an email, maybe even prints out and mails a physical copy of your bill to your home. So this is kind of the high level parts of the service overview. And from here on out, then if you sort of agree that this is the reasonable framework, the parts that I would focus on are this billing service, how it interacts with these two databases, how it populates this billing database, and how this is made available to these other services. Do you think that's a reasonable sort of scope for further discussion?
Yeah, I think that works. Please continue.
Great, thank you.
Tim gave a good high-level overview of his design, outlining the key components and giving a clear explanation of the design architecture. He did well to check in with the interviewer at the end of this section before going deeper into his design. One area of improvement for Tim would be his proficiency with the online whiteboard. He was a little bit slow on it at times. Now make sure you get plenty of practice using online whiteboards before your interview, and ideally, try and find out which exact one you'll be using. Then you can practice with that.
Okay. So, so at this point, we kind of want to drill down further into the aspects of the design that I mentioned. One is, what is this billing service and how does this interact with these other databases? And how do we make it scale appropriately? We probably also want to talk about what kinds of databases each of these databases is. Given that these two databases are kind of inputs to us, we don't necessarily want to constrain what database technology they have to use. Essentially, what we want to be able to do is decide how can we access and utilize these efficiently. So in terms of volume of data, this is going to be our biggest database by far, right? We said that we are generating 1.5 million calls a month. So even if we essentially organize this to keep the most recent, month's data in a partition or subset of the database that we can access efficiently. That's still a lot of records. Every time the billing service, we can almost think of, from a real simple standpoint as a cron job, something that is essentially always running, always going through the customer database, figuring out, finding customers whose billing period has ended, and then going through mining this call records database, integrating that with the customer database and some business logic to then populate things into the billing database. What kind of database would we want to use for this billing database? I think for purposes of making this highly scalable and performant, we probably want to consider a NoSQL database. The particular NoSQL type that might work well for this is the document store. Pardon me, that's mentioned here on our, the document store would be a good choice for this because it kind of is, we're creating a blob of data on a monthly basis that is, essentially that has all that customer billing information for the past month. It kind of naturally fits that notion of here is a blob of data for that is the records of the customer's monthly usage, and then is easily utilizable. Once you have pulled that record, you can use that pretty efficiently to generate the customer's paper bill or PDF bill or whatever your format is. So I'm going to say that this is a document store. And, so this, from the standpoint of this service, then these are both read-only databases, at least for the most part, for the billing service. Maybe there are some cross-pollination, things like we want to populate the customer's state of are they up to date on their bills? Things like that might get populated into the customer database. But for the most part, and at sort of the level of detail that we're talking about in this thing, we're saying these are databases that the billing service is primarily going to read, and then it's using that information to write and create this billing database. A performance challenge for us is how can we efficiently sort of mine and utilize this data, since there are so many records, and we want to find your we said that each customer is going to make 10 calls a day, so we want to find your 300 calls, out of this big pool of 1.5 billion calls. So I think we need to figure out a way how this data can be efficiently sharded or partitioned for our purposes. I think a sort of obvious way to do it is sort of based on a customer identifier. One of the ways that we could, the primary customer database in the phone world, a kind of obvious choice for a customer identifier is the customer's phone number itself. Like for instance, the primary phone number on their plan, and we can do this, and that's what all these records will include, the from phone number that we need to use. So basically, we want to be able to efficiently search this database and find records in a particular time frame with a particular with a particular from phone number. So I left out time day of call. So in order to do that, I would propose partitioning this based on something based on the phone number. A real obvious way to do it is that sort of has also a geographical mapping that could help us geographically distribute and position these databases is like the area code, right? So we could say each area code, for instance, has its own call records database. And if necessary, we could further subdivide that by the next 3 digits of a US area code, the exchange identifier, and break that down. That way we can efficiently go to the shard, based on we're generating a bill for your customer. We know the customer's phone number. We can efficiently identify and go to the particular shard of the database that has the subset of records for that that area code and or exchange, and then this database search that we're doing to generate the customer's bill and find the relevant records becomes much more efficient and allows us to scale our database a lot more easily.
Okay. Yeah, can I interject there? I think that obviously some area codes have very small numbers of customers compared to others, right? So are you going to be able to get an even distribution of data? Are your shards going to be equally sized? And if they're not, is that going to be an issue? And also another point, here in Europe, we don't have area codes for our cell phones, for our mobile phones, as we call them. So how would you do it without using area codes?
Oh, okay. Yeah, those are good questions. So yeah, I would think we'd want to probably be a little more flexible than just area code. So for kind of sparsely populated area codes, we can make this a little more flexible. So for instance, we can say a particular shard covers multiple area codes, or if an area code has too many subscribers that, we want to optimize, we want to partition the database further, we can do that based on the next part of the phone number, in the US, the exchange identifier. Another possible approach, particularly, let's say that it's the UK, for instance. So geographically, it's not nearly as big as the US. There probably isn't, a strong need to, for instance, have different databases in different parts of the country. You could use just a basic hashing function on the user's telephone number as a whole, and just do a hash where you believe that you can get even distribution, and not try to break it down either by some geographical based or other, use a fixed part of the phone number, but just do a hashing algorithm across the entire phone number.
Okay. Yep, that works.
Tim did a good job of drilling down into the databases and how they interact with the core billing service. Database design is an important part of most system design questions. So even if, like Tim, you're not an expert on them, make sure you have a solid high-level understanding. If you haven't already, check out the Databases Guide in our System Design Interview course. Tim sketched out a pseudo code-level schema for the databases. Another interviewer might want to go into more detail about that schema or focus on different types of databases. So be prepared for the interviewer to dive into these areas.
This is a pretty simplified high-level design. Billing service. So, I want to talk about maybe how I've addressed some of the design constraints. The billing service, so scalability. Billing service obviously isn't like just one compute instance. Really, it's got to be a lot of worker instances that are running in the background. We probably need some sort of orchestration system to scale these elastically. So we now have to have some notion of what's the load on the total. How many customer bills are we going to have to generate in the coming day, and then scale elastically the number of actual compute instances that are performing this function and that are going off to service these databases. We probably also, from a geographic standpoint, want to have a notion of that locality. So if we've done this sharding sort of geographic area code or otherwise geographically based, we want to be able to essentially have multiple instances of this billing service, for instance, per area code. That's not exactly what. That so per area code as an example, but not we talked about other things. So if we had a basic area code based system, we could imagine an instance of the billing service per area code, and then this instance is one of its main jobs is to in scanning the customer database is getting a notion of what's the current scale for the current, what's our current demand to generate bills. Do we some notion of predictive? Are we going to be able to generate all the bills that we need in the coming 24 hours? Basically, look at the number. This could just be based on the number of subscribers that we're going to need to generate a bill for, and then spin up actual instances of the billing service, compute instances to actually run the billing service function for each. We could have essentially a queue of that we generate, and so the billing service generates a queue of bills to be generated, and then let's see if I have a good picture for that. A queue of bills that need to be generated in the coming day. So we could have inside each billing service instance a sort of orchestrator that is determining the overall workload and populating this queue. And then essentially a bunch of workers that are servicing the queue. So individual worker instances service the queue and then the orchestrator can elastically scale the number of workers up and down based on essentially the size of the queue. So if the queue grows beyond certain thresholds, you can create more worker instances to service the queue. And so that's probably a little bit of a tricky part that would be determined, I think, probably empirically, how much compute instances you would need to service a queue in a in the 24-hour time frame. And so I guess an important part also is like, is this a hard, is the 24 hours a hard goal or that must absolutely be met, or it's more like a rough, that's the goal. But if we go over by an hour or two, it's not the end of the world, and that would probably be a conversation with our and you essentially probably, if it's the former, then you can be a little more lazy with our allocation, with creation of workers. If it's the latter, we absolutely have to meet 24 hours, then we probably have to be more aggressive, because there's probably going to be some variability in how long it takes to generate these records. And it's, our predictor is never going to be 100% accurate.
To finalize your design, drill down into one of the components that you're most familiar with. For example, if your background is in front-end development, then you could start with the front end, then work your way backwards through the system. This will help ensure that you have time to go in-depth where you have the most knowledge. Tim focused on the core billing service, decomposing it into the orchestrators and billing queue. He gave a good explanation of how it functions and scales. He didn't touch on APIs, which often come up and which we would have needed to touch on if we'd covered the client server. At this stage of your answer, you should also look for any potential bottlenecks and proactively explain what steps you take to avoid them.
So that's kind of the scalability and performance aspects are essentially, they sort of go hand in hand. We scale the system by doing the sharding of both the databases themselves, the database sharding, and then corresponding, creation of multiple of these billing service instances. And then we manage performance by the billing service having the orchestrator, which is filling up this queue, and the workers which are servicing it. And then the workers are scaled elastically based on the size of the queue. So that kind of addresses scalability and performance. And I think with that, that kind of addresses the main points I wanted to cover in this design.
When you finish designing your system, it's time to do a self-check-in. Have you met the requirements you talked about at the beginning of the interview? You should review your design and make sure it addresses each of these points. Tim did this very quickly, but it was enough. Once you're satisfied, check in with the interviewer and see what they think. See if there are any aspects or components that they want you to drill down deeper into, or that you have overlooked. In this case, the interviewer drilled down into availability and security.
Yep, Tim, I think that looks like a very complete design. There is something else I wanted to ask you. You talked about how your design scales, about the performance requirements, but how does your design address availability in the overall system?
Okay. That's a really good question. Obviously, all the data, we have to have a really robust data model. We can't ever lose any of this database. So all these individual databases have to, including the billing database that we're creating, have to, have multiple copies of the data. We can consider, we essentially, it might be, we want data redundancy essentially. So we want to make sure that, for instance, this billing database that we're creating probably has any particular shard has at least, 2 copies, if not more, of the data, so that we never can lose any of that data. Would be an important availability concern. In terms of the availability of our service, to make sure that the billing service is always working, essentially this fact that we probably need to have monitoring systems for this orchestrator. The orchestrator also may need to scale to multiple instances, and so this notion that we always have multiple orchestrators and workers helps make sure that the service can always function, right? Any individual instance fails, all it is essentially a replaceable component that we can spin up a new replacement instance for, and there isn't a notion that there's no single point of failure of the entire system.
Okay. Yep. Good answer.
Tim gave a good description of the availability of the system, explaining how dynamic instances that are using a common job queue addresses availability and scalability because we can scale that pool of workers up and down. Tim didn't get into the specific technologies of the queue or the service bus. That's not his area of expertise. And this brings us to an important point. When given the choice, stick to your strengths. Stay on firm ground where you feel most comfortable about your domain knowledge and the design knowledge. If the interviewer presses you on something where your knowledge is lacking, there's no shame in admitting that you don't know, as long as you haven't claimed to be an expert on it on your resume. It's better to be honest than to try to fake it.
One more thing I wanted to ask you was security. I mean, security is an important aspect of most designs. How would you address security in your design?
Yeah, so security is really important. We're managing a lot of personally identifiable customer information here. One of the benefits of this is most of this, sort of all this portion of the design. Whoops. Yeah, let's see if I can undo that. All this portion of the design is entire, everything except the customer billing portal is kind of inside of our organization, right? It's not externally exposed. It should be all protected by firewalls, not accessible from any, outside public internet sense. We may, for any long-term storage of these databases, we may have to do some encryption of information like this, so that even if our system was compromised and that the database records were accessed, that they wouldn't be readable by an attacker. Those are probably the main things, and then making sure then the main the main sort of avenue. The one sort of publicly accessible part of the system is this customer billing portal that we need to use standard, standard techniques like a reverse proxy server and other, firewall protection to harden this portal to make sure that this could not be used as an avenue of attack into the rest of this backend system.
Okay. Yeah, that answers my question.
Tim addressed the question in a sensible way. This is an internal system, all except for the customer portal, in a safe firewall domain in the organization, and not exposed on the internet, as Tim correctly identified. If the interview was for a security-focused role, he'd probably want to spend more time on security. Depending on the role you're applying for, be prepared to go deeper on relevant topics. In big companies like Amazon, the role or team isn't always clear. So follow that up with your recruiter to try and get as much info as possible before your system design interview, so you can be better prepared to deep dive into role-relevant aspects of the design.
Tim, thanks so much for doing this with us today. How's it been? Have you enjoyed it?
Yeah, it's an interesting problem, and thanks. It's nice to have the tables turned. Usually, I get to watch other people do this, so it's good to get some practice doing it myself.
Absolutely. Well, thanks a lot for doing it with us, and I think it's going to be very useful for people. Hello, I really hope you found that useful. If you did, you can like and subscribe, and why not come visit us at IGotAnOffer.com. There you can find more videos, useful frameworks and question guides, all completely free. And you can also book expert feedback one-to-one with our coaches from Google, Meta, Amazon, etc. Thank you, and good luck with your interview.